Hello everyone, welcome again to Science and Engineering World, where we have been having fun doing mathematics, much more mathematics. So let's go have more fun. In this presentation, I want to look more into the relationship between sine, cosine, and tangent. These are trig ratios which I've done many videos on, and I'll be putting the links more at the end of this video and even some in the column below. You can check them out. My name is Olutola Fakehinde. Before we go on, I would like to encourage everyone, both the old and the new people watching this channel, to please subscribe so that the videos can continue to move faster to other people in the world, and they'll be able to enjoy what we are enjoying here. Thank you for doing so. In the previous videos, which I will put the link up there and some other links below, we have been able to see, using Pythagoras and Secant, these relationships. So I'm just bringing it to refresh our memory, and then we move on. Here in the previous videos, I've been able to establish these relationships that we have here. So please look at the link and then you'll be able to follow us better. Now let's move further to do bigger relationship between these trigonometric ratios. Number one, we've talked about the Pythagoras theorem, and so we have a squared equals to b squared plus c squared. So what if we divide this expression by a squared? That's the first term there. So we're going to have something like a squared over a squared will be equal to b squared over a squared plus c squared over a squared. Now we see that a squared divided by a squared will give us 1, and this will be equal to b over a bracket square plus c over a bracket square. Now if we look at the relationships we have listed above, we see that b over a is cos theta. Alright, so b over a is cos theta, so we're going to bring it into this expression, and so we are going to have cos theta square plus c over a is sine theta, so we're going to put it here, sine theta squared. Now if you look at it, we can now bring the square, remove the brackets. We can now remove the brackets, and then the square will come to the trigonometric, that's cos. So we have cos squared theta plus sine squared theta. So in essence, we can now say here that sine squared theta plus cos squared theta will be equal to 1. So this is another expression that we see between sine and cosine. Let's do the next one. Here we are still going to use that Pythagoras theorem, and we are saying a squared equals to b squared plus c squared. So we have used a squared to divide the expression, so let's use b squared to divide the expression and see what we're getting. So a squared over b squared will be equal to b squared over b squared plus c squared over b squared. Okay, now we can write like we have done before. A squared, a over b all squared will be equal to b squared over b squared will give us 1 plus c over b all squared. Now, like we have seen above as well, we see that a over b is the inverse of b over a, which is cos theta. So a over b is the inverse of cos theta, that is 1 over cos theta squared equals to 1 plus c over b. C over b is tan theta, so which is tan theta square. Now 1 over cos, which is the inverse of cos, is known as secant. So we are going to have sec squared theta, sec squared theta to be equal to 1 plus cos or tan squared theta. So that is the second relationship we are building more. That brings in another term which we are going to look at later on. That's sec. Then let's go to the third one here. The third one, again, we bring in the Pythagoras theorem equation expression. A squared equals to b squared plus c squared. Now we've divided by a squared and then we've divided by b squared. Let's use c squared this time to divide. So we're having a squared over c squared equals to b squared over c squared plus c squared over c squared. Again, we can write the square in brackets, and we can write that and put everything in brackets. So we have a over c into square will be equal to b over c into square. C squared over c squared is 1. Now let's look at this expression. A over c is the inverse of sine. So we are going to have here 1 over sine theta bracket square will be equal to b over c. B over c is also inverse of tan. So that will give us 1 over tan theta squared plus 1. So 1 over sine theta is cosecant. So we write cosecant squared theta will be equal to 1 over tan is cot theta, cot, that is COT squared theta plus 1. So we can write our expression as cosec square theta will be equal to cot square theta plus 1. We have seen 3 new names. The first one we saw was secant. And we said it is it's written as sec and this is equal to 1 over cos. The second one we saw was cosecant. Which we write as cosec, which is 1 over sine. And the third one is cotangent, which is written as cot, and it is 1 over tan. I don't want us to get confused with this, but there is a trick to it, and what I always use is that the first 3 letters in each of these words is what I use. For example, in sec, the 3rd letter is C, and so it is 1 over cos, which is C here. Then in cosecant, it is 1, 2, 3. The 3rd letter is S, which also depicts sine. So this is 1 over sine. And the 3rd letter is cot. 1, 2, 3, which is T, and that stands for tan. So that is 1 over tan. So that is my own little way of remembering these names. I want us to use these 3 trigonometric functions to look at a problem, and it is very interesting. The statement of the problem is, are these trigonometric identities true? And that is to say, sine square theta in bracket sec theta plus cosec theta over cos theta tan theta equals to tan theta plus 1. Now we have two parts to this, which is to say that we have an equation that has the left hand side, where we have the left hand side, which is this, that left hand side of the equation, and then we also have the right hand side, which is this. So the problem is we want to prove, in another word, we want to prove that the right hand side equals to the left hand side, and we can do it from either the left hand side or the right hand side. But let's look at the left hand side and prove that this is equal to what is on the right hand side. We have here left hand side sine square theta in brackets sec theta plus cosec theta all over cos theta tan theta. Good. Now we will see that there is a mix up here with sine and sec and cosec and cos and tan. So the best thing to harmonize them to be one simple straight word. So we can now look at converting the cosec and the sec into the sine and cosine. We can now say here that sine squared theta into sec is 1 over cos, like I said, so that is 1 over cos theta, 1 over cos theta, plus cosec is 1 over sine theta, so 1 over sine theta all over cos theta tan theta. Okay, all that being said, we can remove the brackets, and then we are going to have here sine theta, sine squared theta. We now multiply 1 over cos theta, then we are bringing again sine squared theta here, so we have sine squared theta multiplied by 1 over sine theta all over cos theta tan theta. Now let's focus on the numerator. Looking at the numerator, we can write it again in the form of sine theta multiplied by sine theta over cos theta plus sine theta squared, sine squared theta, sine squared theta over sine theta, all divided by cos theta tan theta. Okay, now the next stage will be left hand side. Again, we are still on left hand side. We are bringing that down, will be equal to, if you look at the numerator here, we see that the first term is sine theta times sine theta over cos theta. Sine theta over cos theta is tan theta. So we can write sine theta multiplied by tan theta plus sine square theta divided by sine theta is going to give us sine theta. Then all over cos theta tan theta. Good. Now, because we have an addition in numerator, we have to split this into 2. So we're going to have here, this is equal to, splitting it into 2, we are going to have sine theta tan theta. The denominator will multiply the two of them, same denominator, cos theta tan theta, plus again sine theta over cos theta tan theta. So this we can write as, looking at this, we see tan theta, we cancel tan theta here. What we have here left, sine theta over cos theta. We have sine theta over cos theta, plus, if you look at the other side, we see that this is sine theta over cos theta, right? That is giving us tan theta. So we now have tan theta over tan theta. So we can now say that our left hand side is equal to sine theta over cos theta is tan theta, plus tan theta over tan theta equals to 1. And you can see from here, examining the left hand side, we see that this is equal to our right hand side, and that is to show that the identity on the left hand side is equal to the identity on the right hand side. Yeah, by now I think we have been able to understand more on trig ratios, looking at relationships between sine, cosine, and tangent, and we've also seen the inverse of each of them, and then we've been able to see more combination of one or two of them together, and this is a very big picture that I have here, and I believe by now we'll be able to solve more problems on trig ratios. If this video has been very useful, give it a thumb up, then share to others so that they can also enjoy what you've been enjoying. Make comments, because like I always say, there are so many methods you can use to solve problems. Subscribe, we need this a lot to be able to make this video and the channel to fly, so that many people will be able to see across the world. And like I always say, keep having fun. Keep having fun. And lastly, until we meet again next time, keep studying.